Welcome to your podcast for Lesson 50, Impulse and Momentum. After watching the podcast, you should be able to define and describe momentum and impulse and explain how to change an object's momentum. Two questions that I want you to think about in the warm-up. What has more inertia, a roller skate or a Mack truck? And what has more momentum, a roller skate rolling down a hill or a Mack truck that's at rest on top of the hill? Remember, inertia can be thought of as a measure of an object's mass. And so for the first question, which one of these is more massive, a roller skate or a Mack truck? Obviously, the Mack truck is going to have more mass and therefore more inertia. But when we start talking about what has more momentum, even though the roller skate has a much smaller mass, it is in motion and the Mack truck is at rest. And so in order to have momentum, that mass has to be moving. And so the roller skate would have more momentum. Okay, so we can think of momentum as inertia in motion. So anything that has mass, if it's moving, has momentum. The magnitude of an object's momentum is its mass times its velocity. And remember, magnitude just means how much. We represent that with the following equation. P, or momentum, is equal to mass times velocity. So if you look at the example that we just talked about, we know that both a Mack truck and a roller skate have inertia, but if the truck is not moving, like it was at rest in that example, then only the roller skate is going to have momentum. Okay. Units for momentum look a little bit confusing, but let's see if we can figure it out using this above equation. So we know P equals mv, and our units for mass would be measured in kilograms, and our units for velocity, common unit, would be meters per second. Nothing cancels out here, and so this is your unit for momentum, kilogram times meter per second. Okay. Understanding that momentum is mass times velocity, since velocity is a vector quantity, meaning it has magnitude and direction, momentum is a vector quantity as well. We can change an object's momentum. We can either gain or lose momentum by changing its velocity. And so if we go back to what we learned towards the beginning of the year, we talked about two different ways that we could change velocity, right? It's either going to speed up or slow down. And from that, we got these equations. The first one was acceleration is delta v over t, and our second equation for acceleration was actually Newton's second law, which says that the acceleration is equal to the net force divided by the mass of the object. And so we can combine these two equations now to show how an object changes momentum. So if I take delta v over t and set that equal to F net over m and do a little bit of rearranging, right, I get Ft equals delta mv. Okay? So some force applied over a unit of time, okay, is going to cause an object to change momentum. The object's mass isn't going to change. What will change is that object's velocity. So it's actually the v that's going to change. One thing you want to keep in mind, when we calculated a change in velocity, remember delta v was always equal to our final velocity minus our initial velocity. So we'll continue to use that to calculate our delta v for this equation. Okay, in this problem, we're given the mass of a truck being equal to 20,000 kilograms, and we're given the speed of this truck at 20 meters per second. Remember, speed we can use as v, velocity, in our equations. It's just that it doesn't have a direction attached to it. Okay, and we're solving for momentum. Okay. Check your units. The mass is already in kilograms. Velocity is already given to us in meters per second, so we don't need to convert anything here. So it's just a matter of plug and chug. So P is equal to 20,000 kilograms times 20 meters per second. Okay. and that is going to give you 400,000 kilograms times meter per second. So answer number 2. Okay, so if an object changes its momentum, what causes that? The cause of that is something that we refer to as impulse. Okay? Impulse is a force exerted over a certain amount of time. So sometimes you can represent impulse, if you're just solving for that, as a given force multiplied by a unit of time. Sometimes you can just calculate the impulse as the change in momentum, so delta mv, or you can set these two things equal to each other, which you see here in this equation. Okay, so looking at that equation, the left-hand side of that equation is our impulse, okay, a force exerted over a certain period of time. So an impulse is going to cause an object to change its momentum. The impulse is equal to how much that momentum changes when that force is applied, and so just like we saw with momentum, it's also going to have units of kilograms times meter per second. Okay, so in this problem, we have a ball that has a mass of 0.06 kilograms, okay, and it's hit with a velocity of 10 meters per second. So initially, we know it's going 10 meters per second before it impacts the side of a house. What is the impulse that the house exerts on the ball? Okay. Well, we know that that ball is going to come to a rest, so its final velocity is going to be 0 meters per second, and I know that I can calculate that impulse by taking delta mv, okay, which is equal to mass times the final velocity minus the initial velocity. Okay. So now when I calculate this, I take 0.06 kilograms, okay, and I'm going to multiply that by 0 meters per second minus 10 meters per second. And when I plug in chug, 0.06 times a negative 10 is going to give me an impulse of negative 0.6 kilogram times meters per second. Now remember that negative sign just indicates direction, and so we've eliminated that from this answer. So number 2, 0.6 kilogram times meter per second is what the house is going to exert on the ball. In this problem, it wants to know if that 0.06 kilogram ball is hit with a velocity of 10 meters per second before it hits the house, what is the force that the ball impacts the house with if it comes to a stop in 0.01 seconds? Okay. So we just solved for the impulse to be 0.6 kilogram times meter per second, or you could start from scratch and say that Ft is equal to delta mv, and since I want to solve for force, I'm going to divide each side by the time. Okay. So our mass again is 0.06 kilograms times our change in velocity. So again, its final would be 0 meters per second minus its initial 10 meters per second. And now all of this divided by a time of 0.01 seconds. Okay. Plug and chug, you're actually going to get a negative 60 newtons, but again, that negative sign just indicates direction. Okay, so answer number 3, 60 newtons. Okay, so let's put this to some practical examples here. So in example number 1, if you launch a steel ball and a plastic ball of the same size out of the same launcher at different times, which ball is going to fire farther? And you should explain this in terms of impulse and changing momentum. What you need to keep in mind with this particular problem is that the two different balls are the same size, but obviously they're going to have a different mass. The steel ball is going to have more of a mass than the plastic ball. The impulse applied to both the balls is going to be the same, though, because they're being launched from the same gun. So that same gun is going to exert the same force over the same amount of time, which is impulse. So even though they're different balls being launched, it's the same impulse. If it's the same impulse, then that means that the change in momentum is going to be the same for the plastic ball and for the steel ball. Okay? Now those different masses come into play. So if you think about the steel ball, right, its mass is going to be bigger, its velocity is going to be less compared to the plastic ball, which is going to have a smaller mass but a much larger velocity. And so if we think about when we started launching projectiles, if I launched 2 projectiles from this same launcher here, it's not the mass that affects it in terms of how far it will go, it's its horizontal velocity. And so if the plastic ball has a larger horizontal velocity, then that plastic ball is going to go farther. So which ball will go farther? Number 2, the plastic ball. Okay, in example 2, you've got a person that's on roller skates, they're standing at rest, and you toss a heavy ball to them. We're going to pretend they catch the ball and that they don't fall over. So explain in terms of impulse and changing momentum what happens when they catch that ball. We know when the person catches the ball, they're going to roll backwards because that ball is putting a force on them. And so what you have to keep in mind in terms of impulse and momentum is that the change in momentum is going to be the same on the ball as it is the person. Okay? And so initially that ball is moving with some velocity. We don't know what it is. But once they become part of the ball human system, when you catch that ball, the mass is going to increase, which means the velocity that that ball is traveling is going to be less than what it was before it was caught. And so that eliminates number 1, because the velocities are going to be different, but we know that that change in momentum is going to be the same for both the person and the ball. Okay? So they will roll backwards with the same momentum as that ball is going to continue to move forward. Okay, example number 3, you again have this person at rest on roller skates. This time they're holding the heavy ball to start, and now they're going to throw it. Okay, again, explain in terms of impulse and changing momentum what happens when they toss the ball. Well, in terms of impulse and changing momentum, we know that the change in momentum is going to be equal for both the ball and the person. Okay? But the ball and the person have different masses. So again, if you think about this in terms of our equation, if we know that their change in momentum is going to be the same, and the ball has a little mass, it's going to have a larger velocity compared to the person, which would have a bigger mass but a smaller velocity. And so the answer choice that is correct here, they're going to roll backwards with less velocity than the ball. Okay, example 4, we're going to look at this in terms of boxing. So we're going to assume that we have a boxer that can throw a punch with all of his weight as fast as he can. So we're going to look at this 2 different ways. Explain in terms of impulse and changing momentum what happens when the opponent leans into the punch. And then we're going to look at it if the opponent leans away from the punch. Well, for this first one, if you lean into the punch, okay, the change in momentum is going to be the same for you and the fist. Okay? But what you do by leaning into it is you make the time shorter. So if you think about what impulse is, remember impulse is equal to force times time. So if I make that time smaller, that means I'm going to make the force of that impact a lot bigger. It's going to hurt more. However, if you do the second option here and you lean away from the punch, we call it riding with the punch, you're going to increase that time of impact, which means that the force that you're getting hit with is going to be less. And so when you watch boxers that are sparring, they obviously want to lean away from that punch because it's going to hurt less.